Hello and welcome to this video. I am Karnesh Jory and this video is about pointers and arrays in the C programming language. And we start with the question, what is a pointer variable? A pointer variable holds the address of another variable. For example, int *ip. IP is a pointer variable. It holds the address of an integer variable. That integer variable is not named. It is indirectly accessed as *ip. And you can see in this example, *ip is of type integer. Similarly, we have pointers to variables of type char, float, double, and even pointers. Yes, we can have a pointer to another pointer. And sometimes the base type is not known a priori, so we have a pointer to void *pointer. And pointer points to generic memory, which can be typecast to a specific type before use. A pointer is not an integer. There is an exception to this. A pointer can have value 0. Now this pointer value 0 has a symbolic name null. That is, we can say int *ptr is equal to null, which makes the pointer variable ptr have the value 0. And when it has the value 0, it points nowhere. It has to be assigned an address of some variable to point somewhere. The ampersand operator gives the address of a variable. This address can be assigned to a pointer variable. For example, if the variable I is of type int and ip is a pointer to an int, we can assign the address of I to ip. We have seen that we can access a variable pointed by a pointer using the dereference operator. Suppose we have an array like this, int arr10 is equal to 21, 31, 41, 51, 61 and so on. Int *ptr, ptr is equal to arr plus 1, which means that ptr points to arr1. We wish to process the array arr using the pointer ptr. So we have expressions comprising of the dereference operator pointer ptr and the increment operator ++ appearing often in our program. All this applies to the decrement operator --, as well. What gets incremented in these expressions, the pointer or the integer pointed by the pointer? Let us examine a few expressions. As a quick recap, both the dereference operator and the increment operator ++ have the same precedence, but they associate right to left. The first one, *++ptr. This increments the pointer and gives what is pointed by the new value of ptr. ++*ptr. This increments what is pointed by ptr. *ptr++. This gives what is pointed by ptr and then increments ptr. Parenthesis *ptr, parenthesis close ++. This gives what is pointed by ptr and then increments what is pointed by ptr. And we can see all this in the program. This array arr10 is equal to 21, 31, 41 and so on, and ptr points to arr1. The first printf prints *++ptr. It prints 41 and ptr points to arr2. The second printf statement prints ++*ptr. It prints 42 and ptr points to arr2. The next printf prints *ptr++. It prints 42 and ptr points to arr3. The next printf prints parenthesis *ptr, parenthesis close ++. It prints 51, ptr points to arr3 and arr3 becomes 52. The last one prints the value of what is pointed by ptr and it prints 52, ptr points to arr3. Arrays is a basic data structure having elements stored in consecutive locations. The elements are identified by the array index. The array index starts with 0. The element with array index 0 is stored at the start of array, followed by element with array index 1 and then element with array index 2 and so on. We can initialize an array by providing the values of elements in the array definition. For example, int arr10 equal to 11, 12, 13, 14, and so on. In C programming, there is a central concept that arrays and pointers are equivalent for the memory occupied by the array plus one element. If you have int arr10 and int star ptr, and ptr points to the start of array for memory locations occupied by the array plus one, array arr and pointer ptr are equivalent. The only exception is that you cannot do arr plus plus or arr minus minus, as arr is a constant. Other than that, you can do almost everything to ptr as what you would do with arr. Both arr and ptr point to array element 0. Both ptr plus 1 and arr plus 1 refer to element 1. Also, we can access the array by using pointer ptr with subscript. So ptr1 is also the same as arr1. This is also useful in passing arrays as arguments to functions. You just need to pass the array name and the function can treat it like a pointer and access the whole array. It is programmer's job to keep track of array index such that you never access any memory outside the array. That is, you never go below arr0 and never go beyond the last element of the array. The system does not enforce any discipline. There are no runtime checks for array index going out of bounds. So it is programmer's duty to ensure that there is no access beyond the 0th and the last elements of an array. As an example, here is a program that prints the array using the pointer ptr. It is simple and more compact than a corresponding program using array index. What are the valid pointer operations? First, we can initialize a pointer to 0. C guarantees that 0 is never the address of any valid data. So that is a nice initialization. When a pointer has value 0, it points nowhere. Then we can add or subtract an integer to or from a pointer. Here we see an important point in pointer arithmetic. A pointer is always for a base type. So when we add or subtract an integer to or from a pointer, that many size of base type times bytes are added or subtracted from the pointer. For example, if we add 1 to a pointer pointing to an integer, the address value in the pointer variable is incremented by 1 multiplied by the size of int, so that the pointer points to the next integer. If two pointers point to elements of the same array, the relational operators less than or equal to, greater than or equal to, equality, and inequality operators can be applied between them. If two pointers have the same base type, they can be assigned to each other. Any pointer can be compared with 0 for equality or inequality. In the C programming language, a character string is an array of characters whose last character is the null character with the integer value 0. It is denoted by \0. When the program processing a character string encounters the null character, it knows that the end of a string has been reached and there are no more characters to be processed in the string. An example of a string definition looks like char arr square brackets is equal to double quotes hello world exclamation mark quotes close semicolon. The compiler puts a null character at the end of the string after the exclamation mark automatically. Now this is a variable character string. The program can modify the characters, but the length of the character string cannot be increased. So in this example program, the string str has the value hello world with an exclamation mark at the end. We can change the second word of the string to Asia, and there is no problem since Asia has 4 characters, which is less than world with exclamation mark having 6 characters. But if we change the second word to abstract, it is an error because we would be going beyond the string length of 13 characters. Length of an array is prefixed at the compile time and cannot be increased at runtime. So, what is the way out? Have the string array big enough for all strings like this. Here, I have defined str to have a space of 32 bytes, which is long enough for all strings I am going to store in this program. Or if you like, you can have a large global buffer which you can use for all your strings. Let's relook at this string ARR having the value hello world. ARR is a variable. The square brackets indicate the size and the blank value in the square brackets is like saying that the size of initialization is good enough. The point is that ARR is a variable and contents of ARR can be changed subject to modified string fitting inside the space available. There is another variety, a constant string. For example, the message char pointer message having the value to erase human, to forgive divine. Now MSG is a pointer to a character and the string is a constant string. This string pointed by MSG must not be changed. If we change it, it would lead to a runtime error. Unfortunately, the compiler does not give an error. We can improve this situation by declaring the string to be a constant like const char pointer msg. And now if we try to modify the string, the compiler gives an error. We have taken care of the problem of modifying a constant string. But suppose we assign the pointer msg to another string. It is legal and works fine, but not so fine because now we cannot access the original string to erase human, to forgive divine. So actually, not just the string, the pointer msg should also be a constant, and we can do that by declaring const char pointer const msg equal to. Now we have an example function to copy source string into a destination char array similar to the standard library function strcpy, and our function has just one line of code while parenthesis pointer dst++ equal to pointer src++ parenthesis close semicolon. A character of src string is assigned to the destination string. Destination and source pointers are incremented, and all this stops when the null character from source is copied into the destination array. Just like we have arrays of integers, float, double and char, we have array of pointers. For example, we have an array of pointers to char star ARR10. Each pointer is a character string. Some of the pointers may be null. These are shown as small cross circles. And we have an example program for array of pointers. Month name is an array of 13 pointers. The 0th element is an error message, whereas month name index 1 to index 12 have the names of 12 calendar months. Given an integer in the range 1 to 12, the function months returns the name of the corresponding month. Suppose there is an array of character pointers, each pointer pointing to a string of month name like January, February, March, etc. We can process this array using array index, or we could process it using a pointer, and we choose to process it using a pointer. To facilitate this, we store the null pointer as the last element of the array, and we define month ptr, a pointer to process this array, and month ptr is pointed to char star, that is char star star month PTR, which is a pointer to another pointer. And this is the program which prints all the months in a year, that is all the strings of array month name using a pointer. The main function of a C program is invoked as int main, int argc, char star, argv, array. The main function gets two arguments, argc and argv. Argv is for argument vector. It is an array of character pointers, each pointer pointing to a string. Argc is argument count. It is the count of elements in the argv array. By convention, argv0 is the name of the program, so argc is at least 1. Since argv is an array of character pointers, we can also refer it to as char star star argv, pointer to char. Using argc we can get all the argv arguments. The example program processes the argv pointer using argc and prints all the arguments. A pointer to a function holds the address of a function, or we can say it points to a function. We can define a pointer to a function as return type parenthesis star pointer to function parenthesis close parenthesis argument list comprising of each argument having type and argument name parenthesis close. If we define a pointer to a function like this, the actual function must have the prototype with matching return type and argument list. Pointers to functions can be passed as arguments to functions stored in arrays and can also be return type of functions. As an example, consider the pthread call for creating a new thread. The third argument of this call, start routine, is a pointer to a function. If we want the pthread library to create a new thread, we must communicate the name of the function the new thread should execute. So this communication of the function to be executed is done by passing the pointer to the starting function. Suppose we have a function name spooler defined somewhere as void pointer spooler with void pointer arg as argument. We can pass the name spooler as a third argument to the pthread call. Of course, we have taken care to match the spooler return type and arguments as required of the start routine in the pthread create call. Also, we can define pointer to a function underscore ptr and assign spooler to it. Then we can pass function underscore ptr as a third argument to the pthread call. And we come to the end of this video. You can find all this information at https://tinyurl.com/c-tutorial4. Please subscribe to my channel and share this video. Thanks very much for watching. Take care and stay safe.